mouse, you can physically pop this into our thing.
Hello guys. So basically today I will be teaching you. So today I am learning the concept of this is the quick sort. So actually what happens in quick sort, this is an inbuilt sort. Whatever function we are using, you have seen in C++, you must have seen that the how quick sort we apply sort using v dot begin, right? Sorry, my bad. V dot begin, then v dot end. I think this is the format to sort. So this is called inbuilt sort. This is called inbuilt sort. In this sort, actually, this inbuilt sort is called is in background. In background, quick sort is being run. The algorithm of quick sort is being run in the background. So I'm trying to make you understand what is how this inbuilt sort, that is quick sort, works in actually what's its algorithm, how the code is running behind that. So for that actually what happens, if you have an array, suppose you have an array, the numbers are like something about 8, 1, 11, 30, 2, 6, 1, 4, 1 and 9. We have an array of, so first of all we have an array of the elements of the array are 8, 4, 11, 13, 2, 6, 1 and 9. So for that you have to find the right, first at first we take the first element of the array and find its right position in the array. So what we do, first we take first element of array and find its original position. We can say it that is original position is it's same as pivot index. Okay, and the first element we can say it is as pivot. This first index will be considered as pivot, and we have to find the index for that pivot where it should fit. If this array is sorted, suppose this array is sorted, suppose 1, 2, 3, sorry, 3 is not there, so 4, 1, 2, 4, 1, 2, 4, 6, 9, 6, 8, 9, 11 and then 30. So if this is array sorted, the position of 8 is at 0, 1, 2, 3, 4, 5, 6, 7, 4th index, right? So we have to find that index where it should be, actually where it should be in the array. What's its index? So and then after that, what we will do, then after the finding the position of the original first index, then we will try to adjust, then after that we will divide this array into two parts. Left half will be of before the pivot point, left half will be of smaller element than pivot, and this right half will be of greater element than pivot. So for that, how to then after that smaller element, we have to arrange that element in this fashion. So for that, what we do, let's look at the code. Include, right now I use string, okay, then after that using namespace std, then after that int main function. Inside this function I will have an array, suppose int add, and the array element is 8, 4, 11, 13, 2, 6, 1, 9. This is array element. So now after in making an array, now I will make a quick sort. Now I will make a quick sort function in which I will pass array, and after array I will pass its initial position, then last element. So for that, for n, int n equal to size of array divided by size of any element of any element you can take, because to calculate the size of array you just have to divide the size of one element by divided by total size of the array. So this will give us the n, then we will pass the n minus 1, so this will be the last element. And after that, now let's make void type, because in this quick sort just we are calculating the how it's calculating, so we need not to make any return type of this function. So quick sort what I will passing here, the quick sort function will be receiving int array and int starting index and int ending index, right? And inside this function, what I will do int I have to find pivot index, right? For the pivot index, what I will do, I will call the partition, because I am going to find the pivot element. We have to partition the array, and in this partition function we have to pass array and starting index and ending index. So after the partition, now let's after the partition, to find the we have to partition pivot index, to participate this partition this, we have to partition this array, and after the partition we will get the pivot index where that element should be in the partition. In the partition this should be return type, because after partition the value will be returned to the partition, and this will be stored into, so I have to make an integer type. So partition, in partition array I am receiving int array and int si and int ei, right? So using this what I am doing after this quick sort partition, right? After this I will be calling, after partition I will be applying quick sort after the partition, after the partition index after getting the partition index, pivot index means the element the first we the element we had taken from the very first position of the array, and then we searched the position of that array. So for that pivot we are searching the pivot index of that element where it should be in the array. So for that, after getting the index, now I will be applying quick sort on the left half of the pivot index and the right of the half of the index. So apply quick sort over the rest of left half. So first of here also I will be passing array, and though starting will be from 0 to pivot index minus 1, right? And again quick sort will be applied to array and p pivot index plus 1 till end of index, right? So up and up else we can see, suppose this is these are the things. Agar suppose what happens if the starting index and ending index is gets equals, means there is no array left. So where will we apply? So for that we have to handle a case, recursion case. If si is greater than or equal to ending index, then return, we will terminate the function, right? So in partition, what we have to do, partition, for the partition what we are doing, we have to partition. So here I will be taking one, I have to find the pivot element. For the pivot element I am keeping it array of si, right? And int I will making it count, initially initialize to 0, then after that apply a for loop from where int I is equal to si plus 1, because after we don't want to search that element only, so we are searching from the next element. So and it will run till equal to end of index and I plus plus, right? And here what I will see, and we can keep it a pivot element, right? And here what I will do after this, I will do check, I will see if array of I is, if array is less than or equal to si, pivot element, then what I have to do, if this is less than that, then what I have to do, I will increase the count. Then I will increase the count to calculate the size, right? To calculate the actual index of the pivot element, right? Now this after this loops gets over, this will calculate the number of elements is less than pivot element, and that this will help us in finding the actual position of the starting element. And after that what we will do, int pivot idx, we have to find the pivot idx. So for pivot idx what I will do, starting index, count plus starting index, right? Because the pivot count plus is added. If count is 5 and the starting index is 0, right? And index is count plus, if count is 5 means its position is 5 and its starting index is 0, right? For this element, if count is 1, the starting index is okay, then I got it. Then what I will do, after getting the pivot index, I will swap the value. I am using the library function of swap. What I am swapping, array of si, means first index, with array of pivot idx, right? I am swapping with that. After the swapping happens, after the swapping happens, now my element is in at the right position, right? My element is the right position. Now what I will do, now what I will do, I will take two variables, one to check the elements from the left and one to check element from the right left to so those will be I, this will be si, and int j is equal to ei, right? Then after that I will apply till what I will do, actually here, if I will check a condition, if array of I to element is passing is less than private element is private element, then what I have to do, I plus plus, then again I will check if array of j is less than and equal to also. So because we are keeping the less element in the left of the private index, if is greater than private element, then j minus minus. This loop will run till I till जब we say until I is less than equal to private idx, right? Private idx, right? And j is greater than private idx, then check this. This will give us the this will give us the this will give us the this will sort our array into this will sort our array according in increasing order. So and after this, and I will check on condition, this I plus plus, and here I will check on condition if array of I is less than, if I is greater than private element, and array of j is less than equal to private element, then do swapping. We will do swap. What we will swap? Array of I and array of j, and after this I will do I plus plus and j minus minus, right? This will give us the result, and as we swap our array. So after this happens, now I want to print my array before quicksort, right? So for int I is equal to 0, I is equal to n, and I plus plus. So before cout right? After this happens, now again I want to after applying quicksort I want to see my array, right? So let's see. After quicksort I want to write out India left to give a, I want to give a next line. So let's see what happens here. Now if you see our array is sorted, right? So how was this interesting, right? So actually what was my approach here? So what I did here, first of all I made an array of random value, then I took calculate the size, then I printed the array, then after that I sent this array and starting index. I made a function with quicksort, and that quicksort will be receiving array, then starting index and ending index. So I'm sending this starting index 0, the total the total array, okay, and the starting index and ending index of that array. So, and then after that I'm trying to find the pivot index. Why I'm trying to find pivot index? Because I want to find a pivot index from where I can partition my from where I can apply divide and conquer. So for that I'm passing the value received by the quicksort to the partition function. The partition function, what will partition function do? Partition function will divide our will try help in finding the pivot index and it will help in sorting the left half. After finding the pivot index, it will help me in sorting the left of the pivot elements left of the pivot index and the right of the pivot index. So here in this function partition, this receiving send, then at first time I'm taking as pivot element as first element of the array. So and then how I will find the exact position of that pivot index? I will count the number of smaller element than the first element. This will give us the number count that how many numbers are there smaller than my pivot element. So the actual position of that element will be there only. So for that I am applying loop from s plus I, because I don't want to calculate my I don't want to run my loop from the similar element, because this will run infinitely. This loop will be run infinitely, because same element, it will visiting the same element and going up next like this. So and now I'm checking the condition. If array of I is smaller than the pivot element, that is right now my pivot element is first element of my array, so I will increase the count if it's smaller. So this count will help me in finding the pivot index. Now what I will do, I will make a variable pivot index where I will assign the value of first element count plus si, because si will be starting index plus count. Then after that I will do the swapping, because I got the position. I will as I got the pivot index, I will swap the value, the pivot index and the si, between si. Okay, then I will take two variables, int I and int j. Int I will be assigned by si and int j will be assigned by the int index, starting index and ending index. Then I will what I will do, I will check if as array of I is as a starting index is smaller than the pivot element. If it's smaller, then I plus plus. If it's greater, then j minus. If j is greater than the j minus minus. If check if this is greater, then left side is any element is greater, or right side any element is or right side any element is smaller, then do swapping, and I plus plus j minus minus. This is the actual the logic of this quick sort. So I think I made you understand what is quick sort. So thank you guys. That's all for today. Now I have some other works. So let's see if I can do it on the YouTube. So that's all for today. Now I have some other works. So let's see if I can do it on the YouTube. So now if you see our array sort, right? Was this interesting, right? So actually what was my approach in that my so sort our array got a using order by weight radius, right? So with that, after the swapping happens, now my element is at the right position, right? My element is at the right position. Pivot index plus 1 till end of index, right? So up and else we can see that so right now I want to register for a course project. So let's see here what project I should register for. So I think this is my UID. How should I type if I have already saved on my pen? This is already saved. KQTI. I want to give an idea for the project. Where is project academics? Project request. Type of project. Industrial problem, design, research, survey, design. Type of project, design, research, fieldwork, industrial problem. Chat, application. Simple features like ban a user sans development. One, two, three, four. Python WebSocket, Python WebSocket, Django, I'm at we will keep nickname. Is all about So I think my university website is not working, so it's fucking hilarious, man. Simply they are forwarding messages and messages to select the project, and right now if I am trying to apply for a project, then there is no option to set. It's totally set, totally shit. Let me see. I think I entered the string. Wait, open it. I think I entered the string, right? But I shouldn't. Okay, let's end this string, guys.